Okay, so we're going to be talking about squares and square roots. When I set up my notes, what's called Cornell style. So in Cornell style notes, Cornell notes, you have this margin. And I just drew a straight line all the way down my page. I need more room than just this little red line, so I make my margin a little bit bigger. So every day you're going to see me setting up my notes like this. Making like a little T-chart. So we have the margin, and then this is where we put the notes. In the margin, we will put stuff like vocabulary, examples, kind of like little topic headers. Okay? So we're going to start out with vocabulary. So over to the side, I'm telling us that this is our vocabulary. Our first vocabulary word is called perfect square. Is a perfect square. A perfect square is a number that is the product Does anybody remember what type of operation the word product relates to? Is it add, subtract, multiply, or divide? You can say it. Not close. It's multiplying. Product means to multiply. So is the product of two equal integers. So a perfect square is the number that is the product of two equal integers. And we talk about perfect square. You've actually already learned this last year with exponents. So let's look at our first example. If I have 4 squared, or 4 to the second power, remember something to the second power is also called squared? So 4 squared means that I'm writing the base number 4 2 times. So you're right. It means 4 times 4, which is, I can't hear you. 16. Good. Yeah, 16. So 16 is what we call a perfect square. And it's called a perfect square because if I modeled this, like back when we did in elementary, it would make a perfect square picture. So let's do that. So 4 times 4, that means I am going to have a section divided by 4 rows. So there's my first 4 rows by 4 columns. So by 4 columns. Y'all remember making these in elementary? 3 times 2, you're making an area model or an array model. So 4 times 4, how many boxes do you think are inside here? 16. And do you see how it makes a pretty perfect little square? That's why we call them perfect squares. So let me ask you, what if I put one more little square and now I have 17 little boxes? Does that make a perfect square? No, I got this little extra. So 17, if I had all 16 plus this one, is 17 considered a perfect square? No, there is no number that I can say a number times itself will give me 17. So 16 is my perfect square. 4 by 4. Okay, give you a little chance to catch up with your writing. Are y'all ready for the next vocabulary word? The next vocabulary word is called a square root. It's called a square root. A square root is the inverse Anybody know another name for inverse from last year? Another name for inverse is opposite. It is the opposite of squaring a number. And I'm just going to use the number symbol to make my notes a little shorter. So if I were to ask you, what is the opposite of addition? Subtraction. Subtraction is the inverse. What is the opposite of subtraction? Addition. Remember those were what they called fact families in elementary school? Squaring, a perfect square, and square root are a fact family. What's the opposite of squaring a number? The square root. So they are opposites of each other. All right, next vocabulary. This one's actually a symbol. It's not a word. It's what people call the square root symbol. It's like a division symbol with that little check mark on the beginning. Got that little check mark out front. And that, the actual proper name for that is called a radical. It's radical, dude. But really, it means the square root of. So it means the square root of something. So it would be the square root of whatever number you put inside underneath the radical. Okay, I'm letting everybody catch up with writing their notes. I'm going to scoot up a little bit. Is that too far or is that good? Okay. All right, so let's talk about an example of a square root. If I were to write this, I would say that as the square root of 16. So that literally reads the square root of 16. What? 4, you're right. Why is it 4? It's 4 because 4 times 4 is 16. So the square root of 16 is 4. Why is it 4? How do we know? We know because 4 times 4 is 16. So anytime you see the square root symbol, you have to think of what number times itself will give me what's inside. What number times itself gives me 16, which is 4. 4 times 4. Y'all ready for another example? I know you can do it. What is the square root of 81? It is 9. Very good, because 9 times 9 is 81. Final answer, put a box around it. All right, I'm going to make myself a little note that tells me I'm going on the back. And it's a super important note. Know these. And you'll see what these are when we turn our page. If you have more room, you can keep going, but I'm going to be writing like a list of things. We're going to be writing our perfect squares and our square roots that we need to know. Most of them you already know, except maybe 3 of them. Can I turn the page? Yes, ma'am. Okay, I'm not hearing anybody object. All right, so the first thing I need to know about perfect squares and square roots is any number to the power of 0. To the power of 0. The answer will always be 1. Any number raised to the power of 0 is always 1. So if I had 15 to the 0 power, what is its answer?
1.
You got it. It's 1. What about if I had 225 to the power of 0?
1.
It is 1 as well. 1,000,000 to the power of 0 is also 1. That's just something that we know, because our number system works on base 10. It makes every number to the 0 power 1. All right, so now we're going to write the perfect squares and square roots that we need to know. Most of them you already know. So how about if we start at 1 squared? What does 1 squared equal? 1 times 1 is 1. 2 squared. 2 times 2 is? 4. 3 squared. Very good, it's 9. It is not 3 times 2. Remember, this little exponent tells me how many times I have to write my big number. 3 times 3 is 9. 4 squared. Yeah, you got it. I'm hearing it both online and in class. 5 squared. 25. 6 squared. 36. 7 squared. 7 times 7? 49. 8 squared. 8 times 8? 64. See, I told you, you already know these. 9 squared. 81. Now we're getting into the big numbers. 10 squared. All right, 100. No fooling you guys. Oh, what about 11 squared? Good. 121. 12 squared. 144. All right, the next 3 are probably the only ones you may not know. 13 squared. Ooh, yes. 169. And then 14 squared. Good job. 196. And then the last one that I want you to know is 15 squared. Oh, rock stars, 225. Now, if you know your perfect squares and square roots up to 15 and 225, you are going to be 2 steps ahead when we start Unit 3 for Pythagorean theorem. Because in Unit 3, Pythagorean theorem will work with square roots. Okay, so now we have all of our perfect squares. Now let's write the fact family for square roots. I'm going to start at the bottom. We're going to go backwards this time. So if I know this is a fact family, 15 squared is 225. What would the square root of 225 equal? It would equal 15, because 15 times 15 is 225. Do you see how they're kind of like back and forth like a fact family? Good. So then if I had the square root of 196, what number times itself gives me 196? 14. Square root of 169. 13. And then the rest of them, you kind of already know because you already know the perfect squares. Square root of 144 is 12. Square root of 121, 11. Square root of 100. Are you seeing the pattern here too? Square root of 81. Good, good, good. 9. Square root of 64. Square root of 49. Square root of 36. So really, I'm just using my perfect squares here. Square root of 25. All right, we're almost done. We're on the home stretch. Square root of 16. Square root of 9. Yes. Square root of 4. Square root of 1. Bam. We are done. We know our squares and our perfect squares.